Good morning, students. Today we are going to see some of the contents that are related to the Git repository. So we will start the content. So these contents are indexed here. Some contents are based on the Learning DevOps textbook that what we have prescribed as a textbook for GCT students, right? Okay, so now let's start the DevOps class 4. So these are the index topics we are going to cover in this DevOps. So the first topic is type of version control system. Second topic features and architecture of Git. And third topic Git command lines. And final topic is branching and merging. So first we will see the types of version control system. So there are two types of version control system. One is represented as centralized version control system, and the second one is represented as distributed version control system. So in this centralized version control system, all the developers or operators will work together, and the repository will be only in the central system, right? So there will be only one remote repository. So all the content of the developers will be stored in that remote repository, right? And distributed version control system, there will be two repositories, that is each and every developers will have their own repository, as well as there will be one a remote repository for their communications, right? So these are the different types of version control system. So first we will start with centralized version control system. So, as the name suggests, centralized version control system has only one central repository. So, this is what I have explained during the introduction, and every developer must be connected to it. The entire project code is stored in the central repository. Even if there are four developers, there is still only one repository for all the four developers. The first type of emerge where centralized system. So these are the some of the centralized systems which are available. Example, subversion system, that is what represented as SVN, concurrent version system, that is represented as CVS, and team foundation version control, which is represented as TFVC, and Microsoft Visual Source Safe, which is represented as VSS. These systems consist of remote server, the centralized code of all developers. So the use of this is it is easy to set up and use. And but there are so many disadvantages based on the centralized version control system. We will see all the disadvantages one by one. So the first one is single point of failure, because since it is depends on a one particular remote repository, if that repository is failed, everything will goes wrong. And second one is dependence on network, right? So all commit and checkout operation need to connect to the central repository at all the time. It cannot be done offline. Everything should be connected to the network for dependency, right? So commit is representing we are committing the from workspace to the repository, we are committing the changes, and checkout is nothing but from repository to workspace, right? So workspace to repository is represented as commit, and from repository to workspace is represented as checkout, right? Next is performance issues. Is all the operations require a connection to the central repository. Because since the load of the central repository is increasing, it may reduce the speed of providing the response to the developers, right? So it may be slow. And next is complex repository organization. If the number of developers and files increases, managing the central repository becomes complex, right? So this is also depend because everything is going to be stored in the centralized repository, so it will be complex to manage. So example already we have seen, these are the some types of examples: subversion system, and then perforce, TFS, and then clear case, etc. Next comes distributed version control system. Git is a best example of distributed version control system, where we are going to see Git in detail in this lecture, right? So in distributed version control system, every developer workspace contain a local copy of the repository. There is no single central repository. The second type of VCS, which is appeared later in the distributed systems such as uh, Mercurial or Git, right? Already we have discussed about Mercurial because Bitbucket is supporting Mercurial as well as the Git VCS system. These systems consist of remote repository and a local copy of the repository on each developer's local machine, right? So there will be remote repository also, as well as there will be local copy of the repository which is available for each developers. So now let's see the advantages of this distributed version control system. It provides local operations itself, so there is no dependence of network. Commit and checkout operations are performed locally, which will enhance the performance. And offline work is also permitted because we are doing the operations locally. Offline work is also permitted. And then next is no single point of failure, because if the failure is in the local repository, it can push the data from the, sorry, pull the data from the remote repository. Similarly, if the remote repository is not working at that current moment, you can update the remote repository by pushing the content from the local repository, right? So network for push and pull operations, right? So we need the network connectivity only for push and pulling the operation. So if you remember the previous demo, I am working in Git Bash, right? So Git Bash, I started working in Git Bash. While I am working in Git Bash, no network connection is required. But while I went to GitHub, for remote repository representation, you may remember that the screen appears no connection because I forget to give the internet connectivity, but I try to extract the content from GitHub. Then only I have given the connection, right? So only for from Git Bash to push as well as from GitHub to pull the content, push and pull, we need the network connectivity. And then next, we are going to see how to, what is the difference between commit and checkout. Already I have told the difference, right? So from workspace to repository, we are implementing this commit. And from from repository to workspace, we are giving checkout, right? So I told from repository to workspace in this direction, but they have given in this direction. That is the only difference. So next we are going to see push and pull. One repository can push changes to another. One repository can pull updates from another. So remote repository versus central repository. Every developer has a local copy of the repository, making the system distributed. And commit and checkout operations are only performed on local repository, right? So these are the two operations performed on local repository, commit and checkout. And remote repository are primarily used to share work with other developers, and it is not for day-to-day operations, right? Once you have completed the work, then you can push it to the a remote repository. So advantages, it is highly available, and the speed is also high and no single point of failure. So examples of this distributed version control system is Git, Mercurial and Fossil. And Bazaar is also one of the example for distributed VCS systems. So next, features and architecture of Git. So first we will see the definition for Git. What is Git? Git is a distributed version control system tool developed by Linus Torvalds, and who has created the Linux kernel, right? So the a person who have created Linux kernel is developed this Git tool. Git is widely used by major companies such as Microsoft, Facebook, Yahoo, LinkedIn, and Intel. So it is not an acronym, but often they used to tell this as global information tracker. But Git is not having any acronym. Next, we will start with the features of Git. So Git is a popular because of the following features, right? So we will see what are the features that are available. So the first one is distributed. Already we know what is distributed. Developer can work offline with a local repository, no single point of failure. Next is staging area, right? So while you are in the current working directory, directly the content will not be moved to the working space, right? So you have to add the content to the current working directory. Adding the content, that is the files, to the current working directory is known as staging area. So it is also known as index area. So Git has a virtual layer between the working directory and a local repository, right? So this is the staging working directory. After that staging area, then to the local repository. From local repository, it can traverse to the remote repository. So files must be added to the staging area before committing, right? So that is what I already told. Current working directory. If you add the files to the current working directory only, it can be added to the stage area. This layer helps developer review their changes before committing, which is not available in other VCS tool like this is what the tools which are available in the centralized versioning system, subversion tool and all, right? So next we are going to see branching and merging. Git allows simultaneous work on multiple branches, right? So far I have given the example in the demo also. Only with the master branch I have given the demo. So with that master branch, you can create multiple branches like B1, B2, any name you can give to these branches. After completing and committing these branches can be once again merged to the master branch. That is also possible, right? So that is what it is providing multiple branches. Branches are isolated from each other, enabling parallel development. Branches can be merged into a single branch. So that is what I told with this example. Next is file movement. So moving files in the Git is also easier, and it is automatically tracks file movement. In other VCS tool, you need to create a new file and delete the old one. But here it will create the versions of each file which is moved. So that is very easy in this Git. So next it is freeware and open source. Git is a free and open source. You can use it freely. And cross platform support, it can support multiple platforms. Next we will see the Git architecture. It consists of two types of repository: local repository and remote repository. So this is the architecture. I will first show the architecture, then we will go to the content. So local, this is a local repository and this is the remote repository. So if you see here, these are the stages which are in this local repository. First, you have to create the working directory. Then if you issue this git add command, then only the files inside the working directory will be added to the staging area. After it is added to the staging area, you are providing git commit to save this file, that is the files which are in the staging area, to the a local repository, right? So git commit is very much important. Until then, the changes will not be saved in the local repository. And once again, if you want to work whatever you have committed, then you can give git checkouts so that you can start working from the working directory itself, right? And git then what we are doing after committing it, we are pushing. So this is the way of pushing the content to the remote repository. First, you have to add the files to the staging area, then perform commit, then you can push it to the remote repository. And if you want to pull the content from the remote repository, you have to use this git pull. And then from this local repository, you have to use git checkout. And after doing all the corrections, if there are multiple branches, you can also merge that branch, right? So these are the this is the workflow of git architecture. So now we will move on to the content. So the workflow, it consists of a separate local repository exists for every developer. Develops perform commit and checkout operation in the local repository. And commit it is of two-step process. First process is add files on staging area using git add. And so this is what commit process, and commit changes to the local repository using git commit. These are the two commands for two-step process in commit. So next, file stages in Git, right? Sorry, file states. What are the files we are having inside that Git, and what will be the state of it? That states are represented here. First is untracked. So new files created in the working directory that Git is not aware of, that is known as untracked. And stage files are added to the staging area and ready for commit. Committed files that have been committed to the local repository. So untracked are nothing but the files are only in this working directory. And the files, once if you have used the command git add, it will come to the stage. That files are known as staged files and committed files. Next is modified files that are tracked by Git but have been modified in the working directory. So this will be represented as version 1, version 2, like that, modified files, right? Like that, we will have different versions of that modified files. So next we will see common git commands. What are the git commands we can use? First one is general git operation, git clone. So this is to clone a repository into a new directory, right? So from the remote repository. So this repository is nothing but remote repository. From that, we are going to clone it to the local repository. So next is git init. So this is to initialize an empty git repository, and git add, adding the working directory files to the staging area. And git move, move or rename files. Git restore, restore working tree files. Git remove, remove files from the working tree and index it. Similarly, we can examine the history and state of the git. Git bisect, so it uses binary search to find the commit that introduce a bug. And git diff shows changes between commits, working tree, etc. Next, git grep, print lines matching a pattern. So we know in Linux also grep command is used for pattern matching. Same process is for this grep also, git also. Next is git log, showing commit logs. Next, git show, show various types of object. Next, git status, shows the working tree status. Next is branching and merging. Actually, this is the important topic. And so far, what are the content we have seen, right? Initializing, adding, as well as committing, and push pull and cloning and all. We have already seen the demo of the git in the previous lecture. Now, after completing this theoretical part of branching and merging, in the next lecture, we will see the demo of how to branch the given repository, and then, sorry, how to branch the already existing repository, and after branching, what are the modifications we can perform. After doing the modification, how we are merging it back to the master branch. These are the content we are going to discuss in the next demo class, right? So for branching and merging, these are the commands we required: git branch, git commit, git merge, git rebase, git reset, and git switch. Next is collaboration: git fetch, git pull, and push. So pull and push, we know pulling is from the remote repository to the local repository. Push is from the local repository to the remote repository. And fetch download object and reference from the another repository. So next we are going to see, so that's all about Git architecture and its features. Next we are going to see Git command lines. So already we have seen some of the commands. And retrieving a remote repository, we are using git clone command. That is also already we have discussed. Next, initializing a local repository. This is also already discussed by giving git init and configuring a local repository. So how to configure a local repository? Git remote add. So you if it is a local repository, no need for this remote keyword. So you just give git add and then the file names what you have to add it, right? So if it is remote, then you have to give the keyword remote, and its corresponding URL should be provided here. Next, understanding the remote aliases. So the name passed as a parameter in the git remote add command allows the remote repository to be identified locally. This name acts as a alias for the remote repository. Additionally, it is possible to configure several remote repository for a local repository, right? Next, adding a file for the next command. So this is what I told, adding the files to the staging area. So this is also we have seen the demo. And next is creating a commit. How to create a commit? Git commit hyphen m and the commit message you want to give, right? Automatically it will be committed and saved in the local repository. Next, updating remote repository. So how to update the remote repository? By using the push command. And if you have any aliases, then you can give that aliases and then the branch name. If you are not giving any branch name, defaultly master branch will be considered. So next is managing branches. By default, when you create a repository, the code is placed in the main branch. That is what represented as master branch, as I told you earlier. How to isolate developments from the main branch, such as for developing new features, fixing bugs, or experimenting with new ideas. You can create new branches from the existing one. Based on the feature what you are going to do, or based on the operation what you are going to do, you can create new branch from the existing branch, and then after that you can merge it back together to integrate their changes. So first we will see how to create a branch, right? To create a branch from the currently active branch, use the following command, right? So git branch and then the name of the desired branch name. For example, let us give feature 1. That means git branch feature 1. Feature 1 is the name of the desired branch name. Next, it is also possible to switch between branches. To switch to a different branch, use the following command. So, for switching, we are using checkout, right? So, for example, if you are working in master branch and if you want to check out to the next other branch, which already it is created by using git branch command, what you have to do, git checkout feature 1. That is what already I have given as an example here, right? So this will change the current working directory to the new branch directory. And next is merging branches. Once you are ready to combine changes from the different branch into your current branch, we can use the merge command. So git merge and then the branch name, right? So for this, for example, if you are currently in the master branch, current branch is master branch, then you can give git merge feature 1. That means this feature 1 will be merged to the master branch. Next is listing local branches. If you give git branch, it will list what are the branches which are available, right? So from this branching and merging along with the demo, we will see in the next class, right? Thank you.